Hello everyone, welcome to the first lesson from Chapter 6, Translations. In this chapter, we're going to analyze ways that we can best show or describe the change in position of a figure. In some of the vocabulary, we will discuss our transformation, pre-image, image, translation, and congruent. Let's define some of these terms now. A transformation is an operation that maps an original geometric figure, the pre-image, onto a new figure called the image. So what we're saying here is that we are going to transform an original geometric figure, or what is known as the pre-image, into a new figure, which will be known now as our image. Okay? And we will do this all through an operation. A translation slides a figure from one position to another without turning it. So now we're going to learn about what translations are. Okay, so let's scan the lesson and complete the graphic organizer. So this is where we would go through the lesson, look ahead, and see if we can come up with a definition for a translation. So now that you see it here, that a translation slides a figure from one position to another without turning it, it means if you're looking at the coordinate plane and you see this image in one place, you can see the exact same image in the other place without turning it or changing the horizontal line or vertical lines or the hypotenuse or anything. It would just be the exact same figure positioned exactly the same way but in a different spot. So simply said, it's a slide without turning or flipping, just as we see it up here. Okay, list three characteristics. Well, the shape, I'm sure, stays the same, the size would stay the same, and the face, the way it's facing, would also stay the same. So all three of those would stay the same. So shape, size, and the way it faces would remain the same. Okay, let's draw an example right here. We see this would just simply move over. It would look like this. You see, I have the exact same shape, facing the exact same way with my hypotenuse here, and the legs being the same, as you can see there. So that would be a translation, just simply a shift to another location, keeping the same shape, same size, and facing in the same direction. What would be a non-example? Well, a non-example would be this right angle right here. Instead of just simply moving it, I reduced the size and I flipped it upside down compared to this. So this would be a non-example. This is not a translation. Okay, so not a translation. Let's take a look at the next question. Here's a real-world example. Carmen created a design at the right on her computer. You can see this design right here. We have this piece right here is just simply called A, and then A1. Okay? Describe the motion involved in moving the design from A to A1. So it looks like it went to the right and then down. So one to the right and one down. Over one space and down one space. Compare the size, shape, and orientation of the design piece in its original position to that of the piece in its new position. So from the pre-image to the image. Well, we can just say they are the same. Okay, it did not change size, nor is it facing a different way. They are the same, but they've just been shifted. That is a translation. And here we have our first key concept, translation in the coordinate plane. And you can see here we have two triangles, and simply it has shifted from this location to that location with all the same angles. Okay, as you can see. When a figure is translated, the x-coordinate of the pre-image changes by the value of the horizontal translation A. The y-coordinate of the pre-image changes by the vertical translation of B. So in symbols, we have xy becomes x plus a, y plus b. When translating a figure, every point of the pre-image is moved the same distance and in the same direction. The image and the pre-image are congruent. Congruent figures have the same shape and same size. So line segments in the pre-image have the same length as line segments in the image. Angles in the pre-image have the same measure as angles in the image. So essentially they are the same, just on a different location. Let's look at the first example. Okay. Example 1. Graph triangle JKL. JKL. With vertices J being negative 3, 4. You can see here we can count negative 3 to there, 4. 1 right there, and 3 for K. And negative 4, 1. Negative 4, 1 for L. Then graph the image of triangle JKL after a translation 2 units right and 5 units down. Write the coordinates of its vertices. So essentially we have to, when we moved left to right, we have to add 2 units to every x value. Okay, and we have to subtract, because we're moving down, we have to subtract 5 units from every y, right, in order for us to be able to move in the correct direction. So you can see here, we add 2 and we subtract 5, add 2, subtract 5, add 2, and subtract 5 from every single one. Okay, and we get our translation. So what does that look like? Okay. From the graph, the coordinates of the vertices of the image is the new image, remember, not the pre-image, are negative 1, 3, negative 2, and negative 2, negative 4. So let's see if I'm right. Okay, if I add, like we said, 2. If we add 2 to negative 3, we get negative 1. If we add 2 to 1, we should get 3. And if we add 2 to negative 4, we should get negative 2. Yep. If we subtract 5 from 4, we should get negative 1. If we subtract 5 from 3, we should get negative 2. There it is. And if we subtract 5 from 1, we should get negative 4. And there it is. Okay, now you can try it on your own. Graph triangle ABC with vertices A, 4, negative 3, B, 0, 2, and C, 5, 1. Then graph its image after a translation of 4 units. So you're going to, 4 units to the left means you have to take them away, right, because you're moving towards the negative side, and 3 units up, and these you would add. Write the coordinates of the image. Okay, let's look what this should move. The translation should look as following. We have our pre-image here and our new image, our image here. Let's see, we have A is for a negative 3, right? A is 4 positive and negative 3 down, right? You run before you rise. In this case, drop. And there it is, right? They're telling us to move left to right. We're going to move 4 to the left. Left is moving in the negative direction. So we're going to take our original 4 and we're going to subtract 3 from it. Sorry, 4 units to the left. So we'll take our original 4 and subtract 4 to the left. So there's our 4, subtracting 4. And then our original negative 3, we have to add 3. See? Because we're moving up. So then in the positive. So what do I get? I get a new set of coordinates that equals 0, 0. Right? 4 minus 4 and negative 3 plus 3 is 0, 0. And there it is. That's my new A. That's my A1. Okay, for my new image. This would be the way to solve it if you were not given an image and if you were not graphing. You would simply acknowledge that if you're moving left horizontally, you are subtracting. Okay? If you're moving right horizontally, you're adding. When moving vertically, if you're moving down, you're subtracting, and when you're moving up, you're adding. And that's how you would solve it without. But you could also just follow the rules where it's saying 4 units left. For each one, we're going to move 4 units left. 1, 2, 3, 4. We move here 1, 2, 3, 4, and move here 1, 2, 3, 4. And now we're going to move 3 units up for each one, right? So then we move up for each one. 3, 1, 2, 3. 1, 2, 3, and 1, 2, 3. And there you have it. So if we were to just simply follow the instructions, we could see our new vertices, right? Right there, and right there. And here's one without the actual graph. We don't get to see the image. So we're going to follow the rules that I just explained to you, but with a table. So triangle XYZ has vertices -1, -2 for X, for Y, 6 and -3, and for Z, 2 and -5. Find the vertices of triangles X1, Y1, and Z1 after a translation with 2 units left. So 2 units left, I already know it's going to be -2, moving in the negative direction, and 1 unit up, so +1. And that's what I have to add. When up and down is my Y, so I'm going to add to every Y coordinate +1, and to every X coordinate, because I'm moving left to right, I'm going to add -2, or simply subtract 2. And you can see that's what they've done here. Okay? So this one is going to have 2 taken away from it. So see, -1 plus -2. And this one's going to have +1 added to it. And you can see that right there. And you get your new set of coordinates. Okay? So now you could graph this translation because now you have your new set of order pairs. Okay, now let's practice that. If you think you know how to do it, please pause the video now and try it on your own. Otherwise, just watch right through. Okay, we have a quadrilateral. Quad means 4. So 4-sided figure, polygon. ABCD has vertices. Okay, so we have ABCD. I will go ahead and make my table with ABCD and then my image. So here's my pre-image. And I will go ahead and write my coordinates down here. And now I will follow my rule. The rule is here in the middle where I know, let's find it here. For my quadrilateral with these coordinates that I've just written down here, find the vertices quadrilateral after a translation of 4 units right. So 4 units right, that means my X will have 4 added. Okay, 4 units to the right, meaning I'm moving in the positive direction, and 2 units down. So my Y will have, I guess, -2 added to it, or you could just say subtract 2. Either one works. So now let's follow that rule, where I have here 0, right, my first coordinate, +4, and my Y, which is 0, plus -2, or just simply -2. It's the same thing, right? And I'm going to go ahead and apply this rule to all my coordinates. So every coordinate, for every X coordinate, I added 4, and for every Y coordinate, I subtracted 2, or you could say added -2. So now I solve, and my new order pairs will be 0 plus 4 is 4, and 0 minus 2 is -2. That's my new A. That's my A1 now. 2 plus 4 is 6, minus 2. That's my B. 3 plus 4 and 4 minus 2. So 3 plus 4 is 7. And 4 minus 2 is simply +2. That's my C. And then 0 plus 4 is 4, and 4 minus 2 is 2, and that is my D1. And there we go. I have my translation now. Example 3. A computer image is being translated to create the illusion of movement. Use translation notation to describe the translation from point A to point B. So we want to show that this little tiger, or I guess little cheetah or leopard, not even sure what it is jumping from this point down to this point. You see that? It's going, we have A, which is sitting at 3, 3, and it's going to go to 2 and 1. So what is our translation? Okay, it looks like we had to go down from 3 to 1, and we had to move over from 3 to 2. So it looks like we have to subtract 1 for the x and subtract 2 for the y. And yet I see that here. Okay, we're going to use, here's our pre-image and our new image. Okay, and as we mentioned before, we're going to replace these variables here of the movement with these variables. Okay, so even though they're not telling us the rule, they are giving us a new set of coordinates. And we know that for x, 3 plus a number equals 2. What can that number be? It's going to be 3 plus negative 1. And here for our y, we have 3 plus b equals 1. That plus b must equal negative 2. And that's how we can solve when given two sets of coordinate. We simply replace the variables and solve. Okay, if you got that last example with the cat moving, then I think you can try this one on your own. It's essentially the same skill. So please pause the video and try it. Pause now. Okay, if you pause the video, here comes the answer now. So refer to the figure in example 3. If point A was at 1, 5, use the translation notation to describe the translation from point A to point B. Essentially what they're telling us is that point A, our pre-image, is not here. Now it's at 1, 5. So we go to 1 and 5. So right there, and I'll put a dot right there so you can see. They want us to know what the new formula, I guess, would be for us to move from here to the B. Okay? Well, first let's count horizontally. We're going from 1 to 2, right? So we have to add 1. Add 1 to the right. So our x will have 1 added to it. And our b will have 1, 2, 3, 4. I'm going to 5 down to 1. It will have 4 taken away from it. So our y is going to have minus 4. If we were to follow this rule, we would be able to translate from this point to point B just fine. Okay, everybody, let's take a look now. Okay, everybody, and here's your guided practice. Please go ahead, take a look through the guided practice. Make sure you feel comfortable with it, and if you don't and you have any questions, please bring those questions to class. See you then.